Hi students, welcome to SSC Excellent Coaching class. So if you are interested, you can join for the passing package course for SLC and PUC. Now let us go for the last class. I left a few lines incompleted that I will continue here. So then after completing, we'll go for today's new feature. Okay, I'll start from this line, that is, most observed phenomena in daily life are rather complicated manifestations of the basic laws. Scientists recognize the importance of extracting the essential features of a phenomenon from its less significant aspects. It is not practical to take into account all the complexities of a phenomenon in one go. A good strategy is to focus first on the essential features, discover the basic principles, and then introduce corrections to build a more refined theory of the phenomenon. For example, a stone and a feather dropped from the same height do not reach the ground at the same time. The reason is that the essential aspect of the phenomenon, namely free fall under gravity, is complicated by the presence of air resistance. To get the law of free fall under gravity, it is better to create a situation wherein the air resistance is negligible. We can, for example, let the stone and the feather fall through a long evacuated tube. In that case, the two objects will fall almost at the same rate, giving the basic law that acceleration due to gravity is independent of the mass of the object. With the basic law thus found, we can go back to the feather, introduce corrections due to air resistance, modify the existing theory, and try to build a more realistic theory of objects falling on the earth under gravity. Okay, ಸೊ ಇಲ್ಲಿಗೆ ನಾನು ಲಾಸ್ಟು 1.2 ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇವಾಗ ಇನ್ನೊಂದು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಂತಂದರೆ, ವಿಲ್ ಗೋ ಫಾರ್ ಹೈಪೋಥೆಸಿಸ್, ಆಕ್ಸಿಯಮ್ ಮತ್ತು ಮಾಡೆಲ್ಸ್ ಅಂತೇಳಿ. ಸೊ ಇದ್ರ ಬಗ್ಗೆ ನಾವು ಸ್ವಲ್ಪ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಲೆಟ್ ಅಸ್ ಗೋ ಫಾರ್ ಇಯರ್. One should not think that everything can be proved with physics and mathematics. All physics and also mathematics is based on assumptions, each of which is variously called a hypothesis or axiom or postulates, etc. For example, the universal law of gravitation proposed by Newton is an assumption or hypothesis which he proposed out of his ingenuity. Before him, data on the motion of planets around the sun, bodies falling towards the earth, etc., each of these require a separate explanation which was more or less qualitative. What the universal law of gravitation says is that if we assume that any two bodies in the universe attract each other with a force proportional to the product of their masses and inversely proportional to the square of the distance between them, then we can explain all these phenomena, all these observations in one stroke. It not only explains these phenomena, it also allows us to predict the results of future experiments. A hypothesis is a supposition without assuming that it is true. It would not be fair to ask anybody to prove the universal law of gravitation because it cannot be proved. It can be verified and substantiated by experiments and observations. An axiom is a self-evident truth, while a model is a theory proposed to explain observed phenomena. But you need not worry at this stage about the nonsense in using these words. For example, next year you will learn about Bohr's model of hydrogen atom, in which Bohr assumed that an electron in the hydrogen atom follows certain rules or postulates. Why did he do that? There was a large amount of spectroscopic data before him, which no other theory could explain. So, Bohr said that if we assume that an atom behaves in such a manner, we can explain all these things at once. Einstein's special theory of relativity is also based on two postulates: the constancy of the speed of electromagnetic radiation and the validity of physical laws in all inertial frame of reference. It would not be wise to ask somebody to prove that the speed of light in vacuum is constant, independent of the source or observer. In mathematics too, we need axioms and hypotheses at every stage. Euclid's statement that parallel lines never meet is a hypothesis. This means that if we assume this statement, we can explain several properties of a straight lines and two or three-dimensional figures made out of them. But if you don't assume it, you are free to use a different axiom and get a new geometry, as has indeed happened in the past few centuries and decades. Thank you, students. We will meet in the next class.